In today's video, we will look at how to subtract fractions with unlike denominators. This will involve finding an LCM and making fractions equivalent. First, let's review subtracting fractions with like denominators. If we have 4 over 5, which we can represent with this circle with 5 pieces, 1, 2, 3, we have 4 parts shaded out of 5, 4/5. Take away 1/5. Which we can represent with this circle, 1 part is shaded out of 5. 4/5 take away 1/5. How do we work that question? Well, we look at the numerator. 4 take away 1 is 3, and we keep the same denominator of 5. Therefore, 4 over 5 take away 1 over 5 is equal to 3 over 5, which we can represent here. 1, 2, 3 over 5. But now let's look at subtracting fractions with unlike denominators. If we start off with 4/5, again represented here, 1, 2, 3, 4 out of 5, and we take away 1/3, which we will represent here with this circle, 1 part out of 3, and we try to subtract them, we see we have a problem because this part is 1/5 and this part is 1/3. We can clearly see that they are two different sizes, and therefore it makes it difficult for us to work with them or to subtract them. So what do we have to do? If you notice that each denominator is different, 5 and 3, and so therefore we have to do something special. We have defined what is called an LCM, the least common multiple, or least common denominator in this case. And first that starts off with finding the multiples of each one of the denominators. So let us find the multiples of 5, 10, 15, 20. We know those from our 5 times table. And let's list the multiples of 3, 6, 9, 12, 15, 18, and so on. Those are from our 3 times tables. Now we look to see which of those multiples are common or the same in each list. We can see that from the multiples we've listed, only the number 15 appears in both. 15 is common, and so therefore that is the least common multiple. We will now take 15, our LCM or LCD, least common denominator, and we will convert 4 over 5 and 1 over 3 into fractions that are out of 15. To do that, we start with each denominator and we ask ourselves, how many times can 5 go into 15? Or 5 times what gives me 15? We know that 5 times 3 is 15, and whatever you do to the denominator, you will do the same thing to the numerator. Therefore, 4 times 3 gives us 12. We've converted now 4 over 5 into 12 over 15. Now let's look at the 3, the bottom number in 1/3, the denominator in 1/3. 3 times what gives us 15? We know that 3 times 5 is 15, and so therefore we say 1 times 5 is 5. We've converted 1/3 into 5 out of 15. Now we have two fractions that have the same denominator. They're known as like fractions, and now we can subtract. 12 take away 5, and we keep the denominator of 15. 12 take away 5 is 7, and we keep the denominator of 15. Our answer is 7 over 15. Let's look at example 2. If we had 7/8 and we wanted to take away 3/4, what would the answer be? We can see that the denominators are different. These are unlike fractions, and therefore we have to start to find an LCM, LCD, and that requires listing the multiples of 8 and 4. Let's list the multiples of 8. 8, 16, 24, 32. And the multiples of 4, 4, 8, 12, 16, 20. And we can see that the common multiples, or those multiples that are the same in both, are 8 and 16. But the least, the smallest, is the number 8. And so we will convert our fractions into denominators out of 8. And we ask ourselves, 8 times what gives us 8? We know 8 times 1 gives us 8. and so therefore 7 times 1 is 7. You can see that that fraction did not change. Now we look at 3/4 and we say 4 times what gives us 8? We know 4 times 2 is 8, and we do the same thing with 3. 3 times 2 is 6. We've changed 3/4 into 6/8. Now we have like fractions and we can do the math. 7 take away 6 as our numerator, and we keep the same denominator of 8. We know 7 take away 6 is 1, and we keep the denominator of 8. Our answer is 1/8. Example 3. 5/6 take away 1/2. Do you notice that the denominators again are different? Therefore, these are unlike fractions, and we have to find the multiples of 6 and 2 to find the LCM, or least common denominator. The multiples of 6 are 6, 12, 18, 24. The multiples of 2, 2, 4, 6, 8, 10, 12, and so on. These come from our timetables, and we list as many as we need to in order to find a number in both that is the same. If we look closely, we can see that the common multiples in red are 6 and 12. And the least common multiple is 6. Therefore, we will use 6 as our denominators in our new fractions. How many times can 6 go into 6, or 6 times what gives us 6? We know 6 times 1 is 6, and therefore 5 times 1 is 5. You can see again that this fraction did not change, and any time the denominators are the same in the question and in the answer, your numerators would also be the same. Now we say 2 times what gives us 6. We know 2 times 3 is 6, so 1 times 3 is 3. We've converted 1/2 now into 3/6. Now we have 5/6 take away 3/6, and we know we just take the numerators and we subtract them, and we keep the denominator the same, and our answer is 5 minus 3 is 2/6. Now, if you look at 2/6, you may say, well, that's not in its lowest terms. There are numbers that 2 and 6 can be divided by to make our answer smaller, and that is correct. In order to do that, we can do one of two things. We can look in our timetables to see where we find 2 and 6, and whatever that timetable is, we can divide by that number. Or we can list the factors of 2 and the factors of 6 and find the greatest common factor, the GCF, sometimes called the highest common factor, HCF, and we can divide both numerator and denominator by that number. Let's do that. Let's list the factors of 2 and 6. The factors of 2, those numbers that multiply together to give us 2, are 1 and 2. The factors of 6, those two numbers that multiply together to give us 6, are 1, 2, 3, and 6. We know 1 times 6 is 6, and 2 times 3 is 6. Now we find the factors that are the same. We see that 1 is in both, and 2 is in both. But the greatest common factor is 2. The biggest number is 2. Therefore, we will divide both 2 and 6 in our answer by 2. So 2 divided by 2 gives us 1. And 6 divided by 2 gives us 3. Let's see another one similar to that. 10/12 take away 2/3. Again, unlike fractions, so we need to find the least common multiple of 12 and 3. The multiples of 12, 12, 24, 36, and 48. The multiples of 3, 3, 6, 9, 12, 15. And now we find the multiples in both that are the same. The only number is 12, and so therefore the least common multiple is 12. We will change both fractions now into fractions out of 12. Already I see that 10/12 will remain the same because the 12 is already in the denominator. 12 times 1 is 12. 10 times 1 is 10. Now we look at the number 3. 3 times 4 is 12. and 2 times 4 is 8. Therefore, we take the numerators 10, take away 8, and we keep the same denominator of 12. We know that 10 take away 8 is 2. We keep the denominator of 12. Again, I know that 2 and 12 are in the 2 times table, and so therefore I can divide both by 2. But let's list the factors of each just to make sure. The factors of 2 are 1 and 2. The factors of 12, there are many of them, and I know that there are several ways I can get 12 by multiplying two numbers. 1, 2, 3, 4, 6, and 12. 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12. Therefore, all of these are the factors of 12. Which ones are the same? 1 and 2. Therefore, the greatest common factor of 2 and 12 is again 2. 2 will not always be the HCF or the GCF. After you list the factors and circle them, you will determine what the HCF will be. Because in this case the HCF is 2, I am going to divide 2 over 12, the 2 and the 12, both by 2. 2 divided by 2 is 1. 12 divided by 2 is 6. Therefore, our answer is 1 over 6 in lowest terms. And now our last example. 3 over 6 take away 2 over 8. Let's list the multiples of 6. And let's list the multiples of 8. Those numbers that are common in red, we see that the number 24 has been listed. If we continue to list the multiples of 6 and 8, we would eventually get to other numbers as well. But we need the lowest common multiple, and in this case, it is 24. We will convert each fraction now into a fraction out of 24. And we start with the denominator and say 6 times what gives us 24? 6 times 4 is 24, so 3 times 4 is 12. Now we go to the number 8. 8 times 3 is 24, and so 2 times 3 is 6. We now take the numerators 12, take away 6. We keep the denominator of 24, and we know 12 take away 6 is 6 over 24. Again, 6 over 24 is not in lowest terms, and I know that because I know in my 6 times table, there is the number 24. Also in the 2 times table, I can find 6 and 24. So which one do we use? Let's list out the factors just to be sure. The factors of 6 are 1, 2, 3, and 6. The factors of 24, there are many of them. 1, 2, 3, 4, 6, 8, 12, and 24. This is because 1 times 24 is 24, 2 times 12 is 24, 3 times 8 is 24, and 4 times 6 is 24. Which factors are the same? 1, 2, 3, and 6. But which one is the greatest? Which one is the largest number? We know it is 6, and so therefore our HCF is 6. We will divide numerator and denominator both by 6. 6 divided by 6 is 1, and 24 divided by 6 is 4. Our answer in lowest terms is 1 over 4. And now you've solved the mystery of subtracting unlike fractions and reducing to lowest terms.